Question number 20, we're going to find the interval of convergence. And so we're going to start with our ratio test. So we're going to set n plus 1 over n, and then we're going to make that less than 1. And once we've done that, we're going to group some of these terms. So we're going to group some of these x terms. We're going to group the x terms, and we're going to group the base 5, and we'll group the n as well, the square root terms. Okay, so starting with the powers, we're going to start with 5 to the power n over 5 to the power n plus 1. So the n's are going to cancel out there. We'll group the roots. So we're going to end up with n plus 1 in the denominator, root n in the numerator, and then we'll group the power parts. So we have 2x minus 1, the n plus 1 over 2x minus 1 to the n. Now things will cancel out here. So we have the power rules for the exponential parts. So we're going to set this up as limit as n approaches infinity. Base 5 becomes 1 over 5. The root, we're going to have to apply a limit to this, and this will become 1. We have root n over root n essentially. And then for the power, the power part, the power series, we're just going to end up with 2x minus 1 once the exponent n's cancel out. Again, this is less than 1, less than 1. So at this point, we can apply our limit. And as we apply our limit, that n over n becomes 1. So we're going to end up with 1 over 5. The n over n becomes 1. So we end up with 2x minus 1 over 5. And then we can multiply that 5 onto the other side. So we have 2x minus 1 is going to be less than 5. Solving this inequality, we have 2x minus 1 is less than 5 and greater than negative 5. So solving the right-hand part of this inequality, we're going to end up with x. We're going to add 1 and divide by 2, so x is less than 3. On the left-hand side, we'll add 1 to get negative 4, divide by 2. We're going to end up with a negative 2 as our left edge. Okay, so we're going to then test our inequalities here. So we'll test the left edge. So at this point, maybe I should make note of the radius. The radius of this, the center is going to be at 1/2, and it looks like the radius is going to be 2.5. So we have a radius is equal to 2.5. And then now we're going to test our right edge and left edge. So I'm going to do a test here. Maybe find some room up here. We're going to test x equals negative 2, and we're going to plug that into our series and checker series. So from n equals 1 to infinity, when I plug negative 2 into that, I'm going to end up with negative 5 n over 5 to the power n, and that's going to be over root n. Okay, so I plug the negative 5 or negative 2 into there. I end up with this. When I simplify this expression, this becomes an alternating series. I get negative 5 over 5 is negative 1 to the power n over root n. And this is an alternating series, and by Leibniz theorem, this converges, or an approaches 0. Okay, so this is convergent. So our left edge is going to be, we're going to include the left edge as part of the interval. We'll go ahead and test the right edge. Okay, when x is equal to 3, we're going to test that. So we'll test when x is equal to 3, okay, plugging into that expression. When x is equal to positive 3, we're going to get 5 minus 1 is n, is 5. Sorry, 6 minus 1 is 5, so n equals 1 to infinity. We're going to end up with 5 to the power n over 5 to the power n, and that's all over root n. And we can simplify this down into 5 to the power n's cancel out. So this becomes 1 over root n. This is diverging. And because the p-series is less than 1. So this is a diverging series. So we don't include the endpoint. So our interval includes negative 2, but it does not include the 3. So the interval of convergence then works out to be inclusive of negative 2, and it's going to be open on the other end at 3.